Hey again guys, here is your foundational video for cosine x. If you've already watched the sine x video, this is really going to be very much like that. If you happen to be watching this one first, well then now you'll have a leg up on the sine x stuff. Alright, so the question is going to be to please, pretty please with cherries on top, find me a Maclaurin series for cosine of x. So again, we start with our basic Maclaurin series setup, which looks like this. Okay, so there's my power series representation in Maclaurin form where I'm centered at 0, and we need to focus again on what these values are so that we can come up with an actual polynomial that will represent cosine x. So I'm going to set up a chart and my n values, my derivatives, and my values at 0. So let's go and see what we can get. Cosine x turns into negative sine x when I take the derivative, then negative cosine x, then sine x, cosine x, negative sine x. Okay, put in 0, I get 1, 0, negative 1, 0, positive 1, 0, etc., etc. So as I said, if you watch the sine x video, this is very similar, except it's all just shifted, you know, basically one row up. So you actually are starting with a 1 this time instead of a 0. You still alternate terms for the ones that have value, and if we list out some of these terms, this is what you get. You're going to get a 1, n is 0, so that's x to the 0 over 0 factorial, which like before is an extremely fancy way of writing something very silly. This is really just 1, isn't it? Okay, but let's just leave it there so you can see all the different terms and all the different pieces, right? The 1 is from here, the x to the 0 is from here, and the 0 factorial is from here. Okay? So I skipped the 0 term, and now I'm negative 1 x to the 2 over 2 factorial, plus, skip a term here, 1 x to the 4 over 4 factorial, and you start to see the pattern now. 0, 2, 4, the next one's got to be 6, 1 x to the 6 over 6 factorial, etc., etc. So it's exactly like sine x, except the powers and the factorials are even instead of odd. And I'm starting at 1 instead of 1x. Okay, so let me just write that one more time. So 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, etc., etc. These are the first 4 terms for the Maclaurin series for cosine x. If I want to write this as an actual formula, well, I am alternating and I'm starting positive, so that's all set. And I have to make sure that all my powers are even. So instead of x to the n, which could be, 0 to infinity, I need to make sure I start at 0 but go to 2. Well, I'm going to make it 2n. I do need to do the same thing for the factorials. Oops. 2n factorial. Sorry. 2n factorial. Make sure that my factorials are all even. So you put in 0 and you can check it. 0 is going to make this positive. X to the 0 is 1. 0 factorial is 1. There's 1. Put in n equals 1. This makes it odd, so negative. X to the 2 over 2 factorial, etc., etc. And this is your Maclaurin series for cosine x. Okay? Now, what if they ask you to find a Maclaurin series for x cosine x? All right, well, take your cosine x and multiply through by x, right? So this is really going to be x times my Maclaurin series for cosine. It's okay. When I did one I think earlier where it was like sine of 2x or something. We replaced x with 2x. Same idea. If I multiply through by x, this is going to be negative 1 to the n, x to the 2n plus 1 now over 2n factorial. I'm basically taking this entire series and multiplying everything by x. So this would be x cubed over 2 factorial, x to the 5th over 4 factorial. So the powers are becoming odd now because I added 1 power to the x. I added 1 to the x term. So this is going to be, instead of x to the 2n, it'd be x to the 2n plus 1, only because I had to multiply through by x. So this would actually be x cosine x. So this is just a manipulation of one we now know. This is one of the core 4. Doing the manipulation is just something you need to be able to do beyond the core 4. And here's one example of that. Okay, hopefully that helps. Again, most of this was really explained for the sine x video. But this should be good enough for cosine. All right, if you have any questions, of course, let me know, and I'll do the best I can. Okay, see you later.